Assalamualaikum warahmatullahi wabarakatuh. My name is Nusha Binti Kamari. So now I'm going to continue part 2 feed-forward control experiment acquisition, analysis, and discussion. So for my part 2 is 2.3, which is repeat the 2.1 experiment by adding a feed-forward KKFF to the system to improve the steady state response. So I create the diagram in the Simulink MATLAB. So VA, we choose the value is 1. For KFF is value 3. And then KB is 2. So this one is the sum. And then this one is transfer function, which is numerator is 0.1. And denominator is 0.5s plus 2. And this one is a pulse generator. And a bit in at the middle of the transfer function also we include a sum, and then for this one the numerator is 1 and then 0.0 the denominator is 0.02s plus 0.2, and then this one is the scope. And then now so this is the result of this query.
My name is Nabila Binti Rizai. Entry number CE19005. For this experiment 5, introduction to Simulink speed control system using Simulink. I will present for the question 2.4. Show the step to determine a suitable KFF and comparing and set the new KFF. Okay, this is the plot diagram that I have created, and this is the gain of KFF. Okay, the old KFF is 3, and we run to see the graph. Okay, this is the graph when the KFF is 3. Okay, now we change the KFF to 5. Run. And this is the new graph for the KFF equal to 5.
As for the discussion, compare all the results above with the expected effects. So for the block diagram in part 2.2, we put the value of k, 0, 5, and 10. As a variable, we connect with the sum and transfer function. So then put with the value of 1 to 3, and we also connect to k, which is variable gain at the value of 0, 5, 10, and 15, and the results will be shown. As for part 2.3, the process is the same, and we just add the gain with a higher value, which is 15, and then we run the results shown. We can conclude that the value is higher than the value and the rise for this part.
Next for the part 3, question 3.2, repeat the 2.1 experiment by adding a feedback control, example integral control, Cs equal to K over S to the system to improve the steady state response. Okay, this is the plot diagram for question 3.2. Is to add the integral feedback. Okay, and the first integral is 0.0, which is this is a load, and this is load 1. And the second feedback for load 1 is 5. After that, click the run. The VA and the KB is same one. The value for VA is 1 and the KB is 1, which is the two block diagram have the same value of the VA and KB. Okay, then run this. Okay, as you can see, and the yellow line is for the load, which is when the K is equal to 0, and the blue line is for the load 1 when the K equal to 5. Next is we change the feedback to N. Also, this is load 2, and this amateur is 15, and this is load 3. Then click run. Okay, you can see the two graph is about the same, and the yellow line is for load 2 is when K equal to 10, and the blue line is load 3 when the K equal to 15. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sunshine and my matrix number is CE190219. So now I'm going to continue for part 3, feedback control, experimental data acquisition, analysis and discussion. So my part is 3.3. The question is tabulate and study the effects of the CS with K equals to 0, 5, 10, and 15. So this is a block diagram. This one is the VA sum. We have a 3 sum, and then 2 transfer function with different value, with different numerator and also denominator. And then this one is a pulse generator, and 2 scope connect with pulse generator, and also the scope is connected to the transfer function. Then we have the KB blocks, and also this one is also the transfer function. So now the question is to change the value K. So the value K is at the numerator coefficient. So now this first one is 0 over x. So I'm going to run it first. Then going to take a look at the result of the scope at pulse generator. Okay, this one one is the graph at the pulse generator. Okay, next, let's change the numerator to 5. So now let's change the numerator to 10. Let's take a look at this code result without pulse generator. And then this one is the result of the pulse generator. The last one is rating. So as we all know that the pulse generator generate square wave pulse at regular intervals, and then the block waveform parameters amplitude, pulse width, period, and also phase delay. It determines the shape of the output waveforms. So that's the result of the value k show the same graph. That's all from me. Thank you.
For part 3.4, discuss and compare the results obtained using these two control methods, feed-forward and feedback control. The feed-forward control produces bigger load disturbance, which the feedback control is considered as the medium option of control method for DC motor than forward control. While from the simulation of feedback control, it shows that the feedback control handles load disturbance better than feed-forward control because the transfer function are able to enforce zero steady state error.